Okay, good afternoon, everyone. Thank you so much for taking your time out of your day to join us for BioGill's first webinar leading up to WestTech 2017. My name is Nick Watkins. I'm the Regional Manager for BioGill at APAC. With me today also are my colleagues Annie Wydert and Dr. Steve Gluck, who I'll introduce shortly. Before we begin, just a little bit of housekeeping. You'll only be able to hear BioGill presenters. All participants have been muted, but you can contact us at any point through the chat box, where you can select to address either the panelists specifically or all attendees of the webinar. You can also shoot through questions at any point, again, through the chat box or through the Q&A box. We'll collect these and answer as many as we can. So as I mentioned, this is BioGill's first webinar leading up to WestTech 2017. We ran a couple last year after WestTech 2016, and we've done a number internationally in the past as well. Today will be a brief overview of our company, technology, and our preferred sweet spots in market, leading into our second webinar, which will focus on project case studies and specifics. As mentioned, my name is Nick Watkins. I'm the Regional Manager for APAC. Today I'll be your moderator. The majority of this presentation will be conducted by my colleagues Annie Wydert. Annie has a Bachelor of it's 3 AM here, Biomolecular Engineering, and has previously worked for Xylem. She's recently joined us and is based in Milwaukee. Also today is Dr. Steve Gluck. Steve has a PhD in analytical chemistry and has worked at Dow for over 30 years, where he was in charge of conducting due diligence on the BioGill technology, and has been working with BioGill in the US for the last 2 years. A brief overview of the agenda. I'll give you a background into our company, a brief history, and the major achievements we have obtained in the last few years. Steve will give you an overview of the BioGill technology, explaining how it works and what makes it unique in comparison to conventional systems. And Annie will take over, giving you an introduction to the BioGill products, our operating guidelines, and sweet spots. As mentioned, we have time at the end for about 10 minutes of Q&A, so if any questions spring to mind, please feel free to send them through, and we'll address them together at the end. The BioGill technology was originally developed by the Australian government at the Australian Nuclear Science Technology Organisation. BioGill was established in 2009 and initially leased the right to use the technology, where it was purchased in 2011 after we had our first major investment from VW Group. The next couple of years were spent primarily establishing a commercial product and understanding the best applications for the technology. And as we started to grow and see success in the Asia Pacific market, we expanded, opening an office in Singapore in 2015. In 2016, just after WestTech last year, we launched our BioGill Tower, which you can see in these photos, which is an amalgamation of all of the feedback and learnings that we had from our initial commercial installations. 2017 has been a huge year for us as well, with offices now opening in China and the USA to support the demand that we're seeing internationally. As you can see, we've got quite an extensive global footprint already for what is a relatively young company. At the moment, we're currently operating in 23 countries, and as of this week, we've got our first commercial sale in New Zealand as well. So that brings up to 24 countries across 4 continents. We have a fully dedicated sales and engineering team supporting all of our offices, which you can see on the map, and we also have worldwide patent protection. I'm now going to pass over to Steve, who will walk you through. Steve, just a friendly reminder, don't forget to unmute yourself, and I'll pass it on to you. Thank you.
Thanks, Nick. I'd like to start with answering that question, how it works. The BioGill Tower, as we call it, is an attached growth bioreactor. In this bioreactor, at the top influent, flows over our gills, as we call it. The gills are manufactured as a ceramic-coated fabric, the ceramic adding the capability for rapid startup and strong biomass attachment. The influent is sprayed by a distribution system over these towers, over these gills, flows down where biological treatment occurs, and exits the bottom. On one side of the gill, we have air, and on the other side, we have water. The air goes in where it's labeled 4 by natural convection and goes out at the air vent on the top. This technology gives you, per tower, a large surface area for biological reaction and a continuous flow of treated water. If you look at the upper left-hand corner, I've got a circle, and on the next slide, you can see exactly what's going on at the gills. So this gill is a sheet of fabric going over a support structure, a rod, if you will, and water flows down where the gills come close to each other, and then there's an air interior which is kept open by a minimal structure. From the air side through to the water side, you get a consortia of biological organisms, ranging in some cases from funguses to anoxic or heterotrophs on the water side. Thus, we get a wide range and a wide variety of organisms that can address our treatment needs. So on this case, we have water on one side with nutrients supplying the consortia through the membrane. The membrane does not pass water, it's wetted. The membrane passes oxygen. That's a confusion that some people have had with our technology when we call it a membrane. They're thinking it's a water filtration device. It is not. On the next slide, we can see how this is put together. In this installation, you see the small pipe going up to the blue lid where water is fed in over a distribution system that's hidden. It flows down and goes out the large pipe at the bottom. And then you can see the vents on the bottom where air is drawn in and air is expelled. There are no pumps. It happens by convection. And in the case of high BOD loads, this is going on, you know this is working because you can actually feel warm air being pushed out the top vents if you put your hand there. That's a good test for operators when they're walking around doing their weekly inspections. So on the next slide, we'll see how it's put together as a system, not unlike any wastewater treatment system. And in this case, it was a projection model we did for a brewery, where the daily flow was 4,000 gallons per day at about 3,500 milligrams per liter BOD, following by some screening or primary treatment capability. In this case, it was a density-based method, into an equalization tank where pH is corrected, and then through 2 stages of BioGill towers and recirculation tanks. Finally, discharging through tertiary treatment as required by the local authorities, and then to an effluent. Most of our clients are looking for about a 90% reduction in BOD, or sometimes to get below 300 milligrams per liter BOD, as was in this case. On the next slide, it's just a combination of what others have told us in terms of how this technology is unique. First of all, it's simple to install and easy to operate. You can see from those pictures, it's towers, it's PVC pipes, and gravity flow, and a few pumps to recirculate and feed. It's easy to maintain. Maybe once a month, an operator opens up the lid and with a garden hose sprays off any accumulated solids. As a tower in and of itself, it's modular and scalable. And because it's an attached growth process, it has a low sludge output, not unlike that of many other attached growth processes, but we're seeing sludge yields of about 1 pound of sludge for every 3 pounds of BOD. And as I mentioned in the first slide, you have both aerobic on the air side and anaerobic or anoxic treatment in the same pass. And this broad consortium of bacteria or fungus give you a high intensity and a high rate of treatment for a BioGill tower. They're used to boost the performance of existing plants as a roughing filter or just to add existing capacity. Of course, they're used for effective and rapid treatment of high-strength soluble BOD. As an attached growth process, we find they're resistant to shock loads and high organic strength waste streams. And this is important for industrial operations where they may not be operating at night or may not be operating on the weekends, but turn the flow up and turn the BOD up during the day. And so we go through a feast and famine cycle, which is normal for BioGill type treatment operations. Without the aeration pumps and direct flow in air by convection, it has a relatively low energy and operating costs, and being aerobic, it's low odor, and having that vertical structure of a lot of surface area, we get relatively compact on-site treatment. So with that, I'd like to turn it over to Annie, who could talk about our product portfolio.
Thanks, Steve. First, we'll talk about the BioGill tower. The tower is the original BioGill product, and it was designed for simple, user-friendly installation, maintenance, and operation. The tower has been operating commercially for the past 6 years now, with the number installed now in the hundreds. During that time, we've continued to make improvements to the product, making it even easier to install and operate. The tower is able to handle a range of treatment requirements, and the design flow rate per tower varies depending on influent loading, wastewater temperature, and treatment levels required. For sewage applications, the flow rate per tower is approximately 2,600 gallons per day for applications needing to achieve 90% BOD removal. For high-strength waste applications, over 22 pounds per day of BOD can be removed per tower. Multiple towers can also be combined in parallel or in series to meet a range of flow and treatment requirements. On the right-hand side of the slide, you can see the BioGill Ultra. The Ultra is BioGill's newest released product, and we're actually going to have our first installation in just about a month from now. For those listening to the recorded version of this presentation, that's October of 2017. The Ultra consists of a 20-foot containerized system with 10 BioGill reactor cores inside, arranged in dual treatment trains for ease of maintenance. The Ultra was developed in order to offer a true plug-and-play secondary treatment solution capable of handling higher flows. Recirculation tanks are built into the unit, and options also include an attached control skid with PLC, recirculation pumps, and an automated self-cleaning option with air scouring, which reduces operator maintenance requirements even further. Like the tower, Ultra units can be combined to meet a range of flow and treatment needs, and flow rates per Ultra depend on influent loading, wastewater temperature, and BOD reduction requirements. For sewage applications, each Ultra can treat over 20,000 gallons per day to achieve 90% BOD reduction. For high-strength waste applications, 90% BOD removal can be achieved with flows of about 5,200 to 8,000 gallons per day per Ultra. Operating guidelines for BioGill systems are pretty simple and consistent with those for other biological treatment processes. BioGill is designed primarily for the removal of soluble organics, so process design should include an upstream screening or settling step to remove the larger particles above about 1 to 3 millimeters in size, and influent TSS should be reduced to about 300 milligrams per liter or lower before water enters the BioGill. Influent temperatures are optimally above 65 degrees Fahrenheit, as colder temperatures impede biological growth and metabolism. For colder climates, many BioGill systems have been located inside insulated structures. pH entering the BioGill should ideally be in the neutral range, but one of the benefits of the BioGill system is that we found it to be very highly resilient to shock loads or to startup conditions that may fall temporarily outside of this range. The system recovers very quickly. Preferred nutrient ratios are typical of other biological treatment systems, and BioGill can also handle fats, oils, and greases, ideally at levels below 100 milligrams per liter. One of the real sweet spots for BioGill systems is food and beverage applications for small to mid-sized facilities with high soluble organic loading. We have a wide range of experience with a variety of applications in the food and beverage market, ranging from wineries to breweries, confectionaries, meat processing facilities, fruit and vegetable processing, and dairy wastewater. We've won awards in particular for high sugar and winery wastewater projects. We really see a niche for BioGill in the craft brewery and winery market, given the simplicity and low operation and maintenance costs, associated with the system compared to other technologies. The BioGill Tower and Ultra are also designed to make it quite simple for the system to be scaled, allowing the wastewater treatment system to grow with industrial customers to expand their operations and increase production. Key drivers for many of our client sites are to achieve regulatory compliance and reduce the cost of high-strength surcharges, especially those who are discharging to sewer and paying per pound of BOD, and those paying for wastewater hauling fees if wastewater is being hauled off-site. BioGill is an ideal solution for food and beverage facilities who haven't previously had on-site wastewater treatment because the system is so simple to operate and therefore not disruptive to day-to-day operations. These are customers busy making their beer or their wine who don't have a lot of time or resources to divert to wastewater treatment. In North America, we currently have a full-scale installation at a winery in Canada, and we have a pilot system currently running at a craft brewery in New Hampshire. We also have additional case studies and full technical reports available if anyone is interested. BioGill also has experience in a variety of sewage applications. The modular above-ground nature of the system makes it quite well suited for decentralized sewage applications or for adding capacity to existing overloaded or aging systems, such as overloaded septic systems, or for retrofitting something like a poorly performing rotating biological contactor while making effective reuse of existing tankage. A major advantage of the BioGill system is that it is robust and highly forgiving, both to fluctuating loads or to periods of operator inattention. It's a great fit for sites like seasonal resorts or golf courses that might see swings and loadings over the course of the week or the year. One system was restarted this spring after a 5-month winter shutdown and was achieving full treatment again after just 4 days. In other situations, we've seen startup occur in less than 24 hours. The limited maintenance requirements and simplicity of operation also make BioGill a great option for facilities that might not have a full-time wastewater operator or the capacity to manage a complex treatment system. We have a number of case studies and technical reports available detailing these sewage applications and others if you're interested in more information. So this brings us to the end of the introduction to BioGill. Key takeaways are that the system is extremely simple both to install, operate, and maintain, reducing lifetime system and personnel costs. It's also a proven technology, installed worldwide, able to achieve effective treatment, especially for low-flow, high-BOD waste streams. BioGill is also designed to be scalable and modular, meaning that the system can be expanded to meet changing facility needs, a major advantage for industrial facilities increasing production, or sewage applications needing to grow to serve additional population or increases in tourism.
Thanks very much for that, Annie and Steve. For those of you that have joined us a little bit later, my name is Nick Watkins. I'm the Regional Manager for APAC, and I'm the moderator for the webinar today. We have recorded this webinar, so if you missed any of the key points at the start, feel free to reach out to Annie, whose email address is on the screen at the moment, and also available on our BioGill website. We're running another webinar on the 21st of September, just prior to WEFTEC, which will cover more specific case studies. I know that obviously everyone's quite busy today at work, and it was really appreciated that you could take time out during your lunch break. So if you'd like any details on these case studies or to join us for the following webinar, please follow us on LinkedIn. It's simply BioGill and the link is there. We'll be posting, I guess, the registration links for the upcoming webinar. We'll also be back at WEFTEC this year. Steve will be presenting a white paper based on an award-winning project we've done with Ferrero here in Australia. And all of those details can be gathered on our social media or on our LinkedIn. Alternatively, please feel free to reach out to either Annie or myself via the emails listed on our website. We've had quite a few questions come through, and I know that we've probably gone over time just a little bit, so we'll get to as many as they can. Please feel free to send a few more through the chat box or the Q&A. You can keep it confidential if you would prefer, and if we don't have time to get to all of them, we'll do our best to respond to you via email shortly. So Steve and Annie, I've got a list here. I'm just going to read out a couple as they come through, and please feel free to jump in on any of the questions that excite you the most. So Steve, I might throw the first one to you. There's just an additional question asking how often the units need to be cleaned and what's involved.
Well, that depends, of course, on the loading and the type of pre-treatment. But in general, our operators find that once a month is sufficient, and what's involved is lifting the lid, doing an inspection, spraying off accumulated solids at the top and between the gills if necessary with a garden hose. During such operation, of course, you're going to get more solids than normal. So they drop into the recirculation tank, and a valve at the bottom of the recirculation tank is open to discharge them so they don't get recycled back into the unit.
Thank you very much, Steve. There's also a question on here asking how long, well, I guess the length of our longest running system. I can talk into that given that I was there earlier this year. It was in Fiji, which was truly just such an unfortunate thing for me to have to visit. But we've been working with Manta Ray Island in Fiji for 6 years now. It's our longest running commercial installation. It's treating resort wastewater combined with commercial kitchens and grey water. And as Annie rightly mentioned, basically our technology has been designed to be as simple to operate as possible. Obviously in Fiji, they've got better things to do, lay on the beach and drink some nice cocktails, and they really don't have time to invest a lot of effort and I guess experience into a full-scale wastewater treatment plant. So we're ticking the boxes there. We've also got a couple systems running on meat processing, juice manufacturing, which have been going for 4 to 5 years now as well. And as Annie mentioned, a number of sites are starting to pop up in the US as we shift our focus. Another question's come through, what's the peak influent BOD you can feed a system? Steve, I think you touched on this, but does it clog at high levels, and is there anything else that needs to be considered when dealing with high organic wastewater?
Well, I think that most of our users are operating less than 10,000 ppm BOD. Of course, we have some peak loads that are up at 20,000 or more, but most of the operations, its average loading is around 5 to 10,000 ppm BOD. The BioGill has a market niche in relatively low flow and high BOD as a treatment solution that doesn't seem to have many other competitors in this space.
Yeah, just to expand on that, the winery that we have running in Canada is obviously seasonal production, as most food and beverage places are. So it's designed to remove a certain amount of kilograms or pounds of BOD per day. As vintage occurs and they're producing more wine, the flow will increase, but consequently you're likely to see a lower BOD. And then, well, I guess conversely, as the flow decreases, the BOD increases, but BioGill's still able to handle spikes of up to 20,000 we've seen. So it really does depend on the influent. And obviously the more biomass that you're growing to remove certain levels of BOD, it'll fluctuate depending on what the influent is and what your treatment requirements are. Another question come through just for a bit more elaboration on plant shutdown. Steve, I know you've done some tests and we've had third-party tests externally talking about the resilience to starvation and restart time. Would you mind speaking into that, please?
Well, we did this on a brewery, and it wasn't necessarily a controlled test and by design, but the brewery goes into no operation on the weekend, and events in some cases actually runs out of flow. So the BioGill, of course, recirculates around, but there's no BOD load. And so this is a starvation cycle. And then on Monday, when there's flow and there's CIPs going on and the BOD look gets high, we still see our 90% removal treatment on the discharge. And so as best as we can tell, it does seem to be able to go through these feast and famine cycles, particularly with, in my experience, of course, is with the breweries, but there have been others in the food and beverage industry that also have these daily fluctuations, which an attached growth system such as the BioGill excels at.
Yeah, we've run a number of projects, as I said, winery and juice processing, both here in Australia and in South America, where we've conducted tests based on spiking either pH too high, too low, starvation periods, hitting it with some disinfectants from CIP. And as Annie's mentioned, we've seen restart times in less than 24 hours. So it's ideal for, I guess, operator forgiveness, if we want to put it that way. As mentioned, a lot of our clients are on the smaller scale and they want to be out there making their beer and making their wine. So some of the more conventional systems aren't as forgiving, which is one of the things that we're really proud of at BioGill, that it is simple to run and to operate. And if something does go wrong, it's quite easy to get back on track. We'll just try and get a couple more of these so we don't run over time, and everyone in the States can have a slightly extended lunch break. How do you remove sludge from the BioGill, and is there anything required to do so?
Well, I think it's similar to what I mentioned. So in normal operations, it's going through a recycle. And then after the recycle, the discharge, since those tanks are relatively well mixed in the recycle operation, the discharge has a settling basin, such as a secondary clarifier, and from there sludge is wasted. Oh, that's how most of them do it if they have to remove sludge.
Yep. And we'll just jump onto this last one now. Are the systems designed as continuous? Are they batch systems? How do you get multi-log reduction? It sounds like someone's been involved in our previous webinar where we were talking through quite a number of our earlier stage projects that were batch. So we have been moving to more of a continuous model. This basically reduces the size and the footprint of the plant required. There's obviously benefits of batch and continuous depending on what you're trying to achieve. Batch system allows for a bit more balancing and specific discharge. So we have a brewery project here in Australia that wanted to design it as a continuous system. However, the local utility required that they only discharge between certain periods during the day and of the week. So it can be done either as a batch or continuous. We can also do the treatment trains in parallel. So you're going to grow a different type of biomass depending on, I guess, the organic load that you're feeding it. So usually for multiple log reductions, we utilize a two-stage system, similar to what Steve was showing in his process flow diagram earlier. And this basically allows the system to adjust more suitably to the waste stream that it's addressing. Steve, would you like to add anything else to that?
No, you did an excellent job, Nick. And,
great. I'll have to put a doctor in front of my name for the next webinar then.
Okay, you do that.
Okay, everyone, thank you so much again for your time. I know it was short and sweet, and we do really appreciate you taking the time out of your day to join us for this webinar. As mentioned, our next one will be on the 21st of September. We'll be going through specific project designs and case studies. And if you have any questions pertaining today or you would like a copy of the presentation, please feel free to reach out to Annie or myself. Have a great day.